So first of all, we're going to hear from Professor Anne Glover, who has a remarkable biography, as you'll see in the profiles in the papers. Very distinguished professor who is now the Chief Scientific Advisor to the President of the European Commission and has been in that position since January 2012, the first person ever to hold that position. She also chairs the recently established Science and Technology Advisory Council of the President. She was formerly Chief Scientific Advisor here in Scotland for a period of 5 or 6 years up to 2011 and holds so many honorary degrees and other distinctions that I won't do any more than refer to the papers and invite Anne to step forward, if you would, and tee us off for today. And I'll just put your first slide up and you press the next button for the rest of them.
Thanks, John. John, thank you very much indeed. Ministers, Dr. Robinson, ladies and gentlemen, I'm delighted to be here, and my task is really to talk a little bit about the science. And the first thing that I would say is that scientists love uncertainty. Okay, it's just for us the raison d'etre. But in terms of climate change, I feel comfortable in saying one thing to you, and that is I am more certain that man is causing climate change in our planet than I am of something, or as equally certain as I am that gravity exists. For me, it's that certain. So what I want to do is to talk to you a little bit about the climate science which underpins our current knowledge of what's happening to our atmosphere. So let's start off with some other things that generally scientists are a bit uncomfortable with, and that would be a few facts. So the first one I think we can look at is that climate change is happening. That is a fact. Second one, human activity is the dominant cause of that climate change. And the last thing that we might look at is that to be able to deal with it, immediate action is needed. So this isn't something that we can continue to deliberate and discuss over periods of time. If we are to protect our position, the human species' position on the planet, we need to act now. Now, I said there that climate change is happening, but the important thing is that it's human activity is the cause, because climate change has always been happening on our planet. So if we go back not very far ago, just 20,000 years, then Scotland was covered in ice. And during that time, the weight of that ice pressed the country down. And because that ice has now melted, in Scotland we are rebounding from that. So in fact, sea level is not increasing for us, it's decreasing as our landmass rebounds. In the rest of the UK, however, they're sinking. So it's a thought. We have to appreciate these subtle differences in what happens to different land masses around the world, and in our case, to one that we are connected with. How do we know that climate change has always happened? And indeed, during ice ages and warm periods, and they happen on average every 120,000 years, so we go through this cycle of warm period to cool period, we know it's happening because we take measurements. So if I just put up two sorts of measurement here, and on the left what we're looking at are the observations from the volcano in Hawaii on Mauna Loa. And here, this is just looking over a period of time from 1960 up to today, 2010, 2012, the last measurements. And so here what we're looking at is carbon dioxide concentration, and we can see it's seasonal because the planet effectively has lungs during the seasons. Equatorial rainforests and so on absorb carbon and then give it off. But the overwhelming trend you can see is that carbon dioxide increases and increases. On the right-hand side, this is historical Intergovernmental Panel for Climate Change, the IPCC data. And you can see that here, if we go back historically, and you might think, yeah, but how did we make the measurements 1,000 years ago or whatever? We didn't make the measurements then, but we can effectively get those measurements now. One of the ways we can do this is to bore into the ice core in the Antarctic and in the Arctic. And in that ice, which is laid down over decades and hundreds and thousands of years, as the ice is laid down, it traps some of the ambient atmosphere which was available at that time and seals it. It's like a time capsule. So you can travel back in time by taking out that ice core, and you can determine what the atmospheric conditions were, what the concentration of CO2 was. And we find that concentration of CO2 does go up and down with natural climate change, generally between 180 parts per million when it is very cold to about 280 parts per million when it is very warm. So that's the sort of distance that we're looking at, between 180 and 280 parts per million. And as I speak to you at the moment, we're just about pushing the 400 parts per million CO2 in our atmosphere. So we are at the moment in a really extreme period. But what's the importance of CO2 in the atmosphere? And you know that we do depend on the greenhouse effect to be able to support human life on our planet, because it keeps us effectively warm. The problem is that what we're doing is we're adding to that, and CO2 obeys the laws of physics on our planet. This isn't something that can be discussed or argued about. It's just one of these other facts that the more CO2 there is, it's like putting a fleece blanket around our planet and we simply warm up. That's the bottom line. And as we warm, some other things inevitably will happen. So ice caps will melt, sea level will rise. So we have then overwhelming evidence over extended periods of time, some of them with historical proxy measurements, and some with measurements that we can physically make today. So we come to the most recent report, and Dr. Robinson mentioned this, the IPCC report, which was published just a couple of weeks ago. And this is the first of a series of reports, but this is looking at the science of climate change. Now, this is not just a bunch of scientists in a room poring over some papers. This represents over 600 scientists being contributing authors, over 200 scientists being lead authors, over 50 scientists being review editors from over 39 countries around the world. This is some body of evidence. And what do they tell us? Well, here are the things, and actually we shouldn't fail to be shocked by what we're hearing. Although it is, if you like, more of the same, the most important thing is that we are increasing in confidence. So we're all the time increasing confidence levels. So we know that the atmospheric concentrations of the greenhouse gases are going up, and that they are as high as they have been for 800,000 years. Now, I mentioned climate change happens in cycles, but the last time it happened that we were during a warming period, you have to remember that the population on the planet was very low. So people could easily move. There was not the infrastructure. There wasn't the vulnerability that we have as 7 billion people on the planet today. Since the 1950s, the IPCC report states that it's extremely likely that human activities have been the dominant cause of the temperature rise that we see today. Now, extremely likely, again, it's the language of scientists, and for us that means it's pretty much a sure thing. So I think what the IPCC does to us and for us, which is very useful, is it starts categorizing what's very likely, probable, possible, and not very likely. And so we need to look at those things carefully, and I'll come back to this. Why is this happening? Because burning of fossil fuels, as what we have used mainly to fuel our industrial development across the world, and that's behind this increase in CO2 concentration. The second point that I would like to mention from the IPCC reports is that temperatures are likely to continue rising. Because it's an average, I mean, if I say to you today, the average global temperature today is 12 degrees C. So if you take the average over the whole globe, the Arctic, the Antarctic, the rainforest, equatorial regions, and our temperate regions, the average world temperature is 12 degrees C. When it increases or decreases, it's likely to do so in an uneven way. So some places will get very much warmer, and others will not see the same temperature increase. Similarly, some places get wetter, some places get drier. I think what we can say is to look at that second bullet point, that to avoid dangerous levels of climate change that we will not be resilient to as a global population, we need to limit climate change to 2 degrees centigrade. That's becoming very certain in the minds of the thousands of scientists who are working on this issue. And I think here for us is the most difficult thing to grasp, I think. And that is that to be able to achieve or to have any chance at all of limiting ourselves to just a 2 degrees average global temperature increase, and that's actually a big temperature increase, then we can only emit so many gigatons of carbon dioxide. And that estimate is between 800 to 880 gigatons. Now, the fact is that out of that amount, we've already put 530 gigatons into the atmosphere. So we've a very small amount left that we can afford to put into the atmosphere. And I think this is quite a sobering way to think about it. So, in effect, to have any chance at all of maintaining just a 2 degrees average global temperature rise, we have to leave at least 50% of all the carbon fuels that we currently know about in the ground. And that's quite some challenge. Sea level rises will, of course, continue to increase, and most of the increased heat in our atmosphere is actually going into our ocean. About 90% of the increased warmth in our atmosphere is going into the ocean and is starting to warm the deep ocean. And what that means is that ocean currents will start changing, and we depend very much on ocean currents to be able to keep some areas which should be cool warm. And also ocean currents are fundamental in our temperature and also our climatic responses globally. I'm going to put up this just very briefly and not take you through it. This is all about radiative forcing, which is a fancy name for energy in versus energy out. But on the right-hand side, what you're seeing is where there is more energy coming in and it's not being radiated out, so we're capturing it because of this fleece blanket around our planet. So the top three are the greenhouse gases where we've got very high levels of confidence. That's the right-hand column here. And then we can go down. There are some things that we do, like changing in land use, increase, for example, in forestry, and other changes of land use, where we might be able to, in fact, capture some of that carbon, so reduce the radiative forcing. Some of those you might see are low confidence. So we've got a low confidence that they're having the impact, the positive impact that we might see. The stunning thing is at the bottom three panels there, three columns, this is the amount of radiative forcing, the amount of increase in temperature that we're responsible for, the anthropogenic radiative forcing. And you can see that from the 1950s, we had a small amount, to 2011, where we have substantially more. Climate events and weather events are often related, although of course they're not the same. But just have a look at this graph here, where we're looking at natural disasters here from the 1980s through to 2012. And in a very short window, just 2 decades, you can see the increase. If you look, these are total losses in the red column. So you look at the total losses from natural disaster, which are climate related, such as flooding here in Germany in the Saxony region just this year. So there is substantial human cost and financial cost that we already see from climate related events. It happens across the world. So it happens in Europe And as I speak to you today, the vast majority of the Netherlands are below sea level. In the UK, in East Anglia, a very large proportion of the landmass there is below sea level as sea level continues to rise. And we can see, and I've circled just the Mediterranean region of the European Union. So there we already have severe conflicts around availability of water, as the availability particularly of freshwater resource decreases substantially. So a lot of the events that you hear in the news, such as the tragic events around refugees in Lampedusa, those refugees, a lot of them, are fleeing from areas where it is not sustainable to live in a decent way because of climate change impacts, and in particularly in that case in water shortages. In the global south, then we look at areas, and unfortunately, and it's been mentioned before, it's those who are sometimes least able to cope who have to bear the greatest burden. And particularly, we should think of some of the megacities in the world, like Bangkok and Dhaka. These megacities now are very vulnerable to any increased sea level rise or temperature rise. It's very hard to be resilient in these megacity structures. And so we have an enormous challenge to be able to address that. The decisions we make, so what scientists, what we and me and my colleagues, what we do is to provide the evidence. And we need to make decisions on the basis of that evidence. And here, whether we are extracting oil from the North Sea, taking flights, driving traffic, or whatever, they do have impacts on people elsewhere. So this was what was quite a high-impact visual event where the government of the Maldives had a cabinet meeting underwater, because that's where they're likely to be if globally we don't manage to limit climate change. So just in conclusion then, to say that what scientists have to do is scientists need to continue to produce the evidence and to try and deliver reducing uncertainty around some of the crucial issues of the impact of the climate change. So we produce the evidence. Science also can produce solutions. So there are options that the evidence would lead us to, a variety of options of how we might respond to what is the biggest global challenge we have ever faced. But we need to act. And I think what I would say that it is up to scientists, and scientists absolutely must challenge when the evidence that we generate is misused or misquoted. We must act. But I think also citizens must act. If politicians do not take the leadership that's required of them and act upon the evidence that science provides. Thank you very much.
I'm going to exercise my privilege of asking a couple of questions to Anne, and then I'll take one, possibly two questions from the floor very, very quickly, not statements, just questions to allow us to maintain momentum. And halfway through, I thought, well, most of us know all of this, but as your presentation unfolded, it became just more and more salutary, and again, you drove home the seriousness of this. One fact that struck me was that in order to achieve a 2% or 2 degree only increase, we have to leave 50% of carbon potential in the ground, I think, if in layman's language. My understanding is that the economic models upon which much of big business and government policy and other investment is built assume that much of that will be extracted over the next few years. So from a science point of view, how do you address that and the interrelationship with economics?
So that's a very difficult question, probably one that you need to address more to an economist. But from my point of view, what science can do is say what you need to deliver. And I mentioned that we need to keep, and we do need to keep, 50% of all the oil, coal and gas reserves that we know about in the ground. But of course, they make up the assets of many of the largest global companies. And if you just wiped off some of their assets from their balance sheet, there would be a big problem in the global economy. So what science can do is to offer options around how we might be able to capture some of that carbon, because if we are to take it out of the ground, we cannot afford to let any of the carbon go into the atmosphere. So we need to accelerate our thinking around carbon capture and storage, alternative energy. But one of the things that I would say, and for me it really hits it home, just as a citizen, not as a scientist, that we used to use wood as an energy source. And when we discovered coal, we didn't stop using wood. In fact, we increased our utilization of wood when we discovered coal. And then we discovered oil. And when we discovered oil, we increased our consumption of coal and wood when we got oil. Then when we got gas, we increased the oil, the coal and the wood. I think you're getting the message now. So at no time, even with the introduction of renewable energy resource, whether it's solar power, wind power, wave power, tide power, whatever it is, we still increase the consumption of all the fossil fuels. And I think that the only solution for me is that this is such an important issue. We need to get the scientists in the room who, if I had to describe a scientist to you, we never have problems, we just see challenges. So somebody comes along with what someone else sees as a problem, we think, great, you know, this is something for us to solve. But we need to keep them, the scientists in the room, with the economists and the politicians to be able to come up with what is a workable solution. If you keep everybody apart, which is currently what we do in global governance, that won't work.
And that perhaps leads to my next question, which is about today's angle, which is climate justice. What is the European Commission or European Union angle on this question of climate justice insofar as it relates to the scientific issues that you set before us?
Yeah, and I think that we are very lucky, in my view, in that we live in Europe and we're part of the European Union, because like Scotland in the European Union, there are very challenging targets around climate change. And for the European Union, the focus is on those countries who have not caused the problem, but who are suffering the greatest impact. So what to do then? And I think here, certainly in the European Union and the European Commission, we're working hard with countries that are suffering the very negative impacts of climate change and will continue to suffer them, but also hoping in some way to learn from them. So this is not a relationship where we just say, well, you should do this. It's a relationship where we try to understand some of the possibilities around leapfrogging technology. The developing world does not have to develop in the way that we have developed, because in a way that's history now. They could develop in a way that could show us a different way forward. So I think there's a very strong emphasis on dialogue at the European Commission to try and identify how can we learn from different ways of thinking, because we tend to be very blinkered in the West, in the developed world.
Thank you for that. Really important to remember that this is a two-way street, not just one way. Now, because of time, I'm going to take one question for Anne, if there's a question lurking anywhere.
Excuse me.
One question just right down here. If you have Tessa or Louise with a microphone. You're so far away, I should have picked somebody at the back of the room, but is it coming? Tell you what, sir, would you mind just standing and I'll repeat the question?
My name is Keith Alverson. I'm from the UN Environment Program.
Yep.
I'd like to follow up on the scientific conundrum, which shows the difficulty of achieving 2 degrees C. In the first presentation, we heard Scotland's very ambitious emissions reduction scheme, 25% to date, 40%.
I'm going to ask this kind lady to give you a microphone so that everybody can hear. Keith, can I ask you to keep this short to a question, if possible, please?
Yes, Keith Alverson from the UN Environment Program. Scotland, in the first presentation, suggested its strong support for holding warming to 2 degrees C. Scotland then showed its extremely ambitious reduction plan to 80% of reductions by the year 2050, I think it was, 40% by 2020. I would argue that from the presentation we just heard, even if all countries in the world achieve that reduction rate, we will not hit the 2-degree target.
I'm going to take that as a question, Anne, and I'm going to pose it to you. To what extent is Keith right in that analysis, and if he is, what follows from it? And if I can ask you to keep that a fairly short answer as well.
Yeah.
Thank you.
If you're asking me if I think all the pledges that have been made globally are sufficient to limit us to a 2-degree rise, I would say no. So I think that, I mean, I can't give any more of an answer than that, in that it won't. And so we need to do something, actually we need to do something different. It's not just, okay, so maybe it has to be 85% or whatever. I think we need to think completely differently. And the plus side, the optimistic view is we can do this. It is amazing what we can do when we are set challenges. What we just need, and it's been mentioned already today, we desperately need leadership to be able to deliver that.
Thank you very much. So it's not a problem, it's a challenge.
Yeah.
Which we can meet. And thank you very much indeed for your very articulate presentation and answers. Thank you. I'm now going to keep sitting, but invite Ian Marchant to make his way to the lectern if he would. Many of you in this room from Scotland will know Ian. Ian has recently retired as Chief Executive of Scottish and Southern, or SSE, one of the largest energy companies in the UK. But throughout his period of leadership of that company has been an inspiring and engaging and sometimes quite irreverent leader in the field of addressing climate change here in Scotland, particularly as the chair of Scotland's 2020 Climate Change Delivery Group. So without further ado, I'm going to ask Ian to give us his thoughts from the business perspective. And I rather sense that today that what we're seeking to see is how and to what extent business can help to play a very significant role in addressing these challenges around climate justice and climate change. Ian.
Thank you, John. Good morning, everyone. So what is the 2020 group? Mary Robinson asked me for the elevator pitch last night. I have to say that Mary is one of the most persuasive and forceful people I've ever met. I would